hope that that is now fixed. What's happening? Okay. I wonder if it's the same link. Shareable link. Sick. Is it the same link? Let's see. No, it's not. Sorry. That's good enough for now, I think. I'll just give you a second to rejoin. Tina's here. Yes, let's go. Okay, so comments are working. Good. Feel free to ask questions, by the way. I'm just going to take a second to let other people get back in as well. I'm gonna take a drink. Did I download mass spectrometer? I did. Good. Not gonna worry about that. There we go. Yeah, sick. Okay. I feel like I'm being really loud. Am I really loud? Tell me if I'm really loud or if I'm not really loud. Hi, Ella. Not loud, perfect. Okay. Have you got any questions so far? Sardine. Hello, Sardine. I'm sorry, I don't know who you are. But welcome regardless. Is this gonna be assessed? Well, let's see. Let me just bring it up. So here. So what is meant by it? So terminology. Sardine sadhana. Okay, perfect. Okay. So terminology. So definitions. Use diagrams to outline the processes. So that's something like this. A diagram like this would be perfect. Wait, whoa, sorry, that's the wrong thing. I've just misled you. How dare I? That point was a diagram like this. The excited state and ground state one. You need to be able to show me that electrons can go up and go down, and then absorb and release energy, that sort of thing. Next point, what is an absorption spectrum and how does it differ from an emission spectrum? This is the PowerPoint that we did today. Sorry, I'm burping a lot. You didn't need to know that. Let me just download it. Give me a second. Here. Where are we? Here's your two different spectra. So absorption spectra has dark lines, emission spectrum has colored lines. And why is that? Absorption spectra has dark lines because those wavelengths have been absorbed. Emission spectra have colored lights because those wavelengths have been emitted. Wavelengths emitted by electrons when they go from a high energy state to a low energy state. Keywords there for you. Back to this. For examples, literally just gonna copy paste and see what it comes up with. Why did I have to create a channel in order to speak? Hi sir, hello, EJ. Now, okay, this is embarrassing, but I have to go to the role to see who EJ is, unless you tell me before I find you. Evan Johnson. Why did you have to create a channel in order to speak? Okay, don't bro me. I'm about to ban you. Don't bro me. I'm not your bro. So this question, sorry, I've got sidetracked a bit. This question is just asking you, in Australia, how would this technology be used? So, Australia, mining is huge, right? Oh, that's not how you spell ChatGPT. Oh, is this gonna expose everything that I've... Yeah, kind of. Oh, that's so embarrassing. So there you go. Sick. Environment, food safety, forensic science. I'm teaching forensic science this year, and mining. There you go. There's your 4. And the question here is asking. So first of all, what are they? So that's sort of like a list question. What are they? So you'll give me 4 examples, and then how is it used in those 4 things? So you will say it's used in food safety. How is it used in food safety? It's used to determine the presence of trace elements, that sort of thing. Wait, your favorite student? Not if you can't spell favorite. Oh, Ella's everyone's favorite student apparently. If you're everyone's favorite student, are you anyone's favorite student? No, that doesn't make sense. Are you sure about that? If you did some other stuff, that's fine. This is just what Mr. GPT is saying. Like if you have something else, like it's not like Australia has only 4 industries. If you have something else, go ahead. Oh, hi Angel. Oh, I didn't even realize it was Angel. It's just so many cat profile pictures. It's kind of hard to tell them apart. That didn't make sense. Wait, what didn't make sense? Did I say something wrong? What didn't make sense? Okay. Right, I feel like I've got sidetracked a little bit, and let's get. Oh, when you said if I was everyone's favorite student, yeah, it didn't make sense. It was yeah, yeah. Apologies. Oh, here's a question. Let's go. Oh, okay, sir. For atomic absorption spectrometry, right? Would I need to know about the voltage? And like the role of noble gases bombarding the cathode in a process called sputtering. Hi, Kevin. Evan, I'm going to show you. Control F. Find in this document. Noble gases. Not in this document. Okay. Sputtering. Not in this document. Voltage. Not in this document. What does that say to you, Evan? No, don't worry about that. Don't worry about that. Like noble gases bombarding with the ions to make them excited. I mean, I'm not really seeing that anyway. I think you're doing too much. I think you're doing too much. Thanks, Ella. Top 10 2025 chemistry coldest moments. So in mass spectrometer, how does a mass spectrometer differentiate between ions with the same mass? Same mass? Ooh, that doesn't sound right. Kevin, we haven't done the mass PowerPoint yet. I'm gonna do the mass PowerPoint in a second. Oh wait, I'm looking at the wrong one. My bad. We haven't done the mass PowerPoint yet, we've just finished the atomic one, and I'm just going through the different points and what you might or might not need to know, and then we'll do the mass PowerPoint. It's not in the test. Evan, no, you don't have to tell me about noble gases and such, because the PowerPoint didn't say it, and you are only in year 11. Can I get a shout out? Leon! Shout out Leon! Okay. I think let's get back to chemistry. What is the main components of the atomic absorption spectrometer? Draw a basic schematic for a typical absorption instrument. So basic schematic, when we say schematic, this is what we're looking for. Like I don't need detail like this diagram. That's too much detail. It's actually confusing. So don't do that, please. Instead, can you just do very simple diagrams to show me the different parts of the machine? As long as you know how to label and know what the labels are, that's what we're testing. We don't need to know that you can draw. Pashva, why are you here? Get out of my class. Why do you have access to my class? Bro just walked into my class unannounced. Do we need to do bibliography because my teacher said he don't? Okay. But the other teachers are asking for it. Is there a point if it's not marked? Don't talk to me about this. Don't talk to me about this. I'm not your teacher. Going behind your teacher's back? It's not very nice. Fragmentation patterns. Again, bro, don't. Just chill. We're not doing fragmentation patterns. Just wait. We haven't gotten there yet. Just there's a sequence to things. Anyway, here's a diagram. Easy diagram. That's it. What is the process of calibrating? The calibrating part, that's this slide here. Is it? This one. Oh, no. This one. So the calibrating is not actually physically calibrating the machine, but it's trying to get this curve. That's why it's called a calibration curve. Go figure. More comments. Wait, feel free to leave. Oh my goodness, it's getting toxic now. Yeah, tell him, Evan. No fragmentation. I've been saying. Second. Okay. All right. Use a list of steps or a diagram to illustrate. is prepared for analysis. So when we're saying prepare for analysis, this is what we're talking about. How do you come up with this curve? Where are you getting these values from? You need to know your original concentrations, put it through the machine, get the absorption values for those concentrations, and there you go, your machine is calibrated. Sick. Once an instrument is calibrated, explain how concentration values for a sample of unknown concentration is determined. Like I said, just here you go, extrapolate, go from your absorbance to your concentration. I feel like I'm saying the same thing over and over. I think we should probably move on. How can solid and liquid samples be prepared for analysis? Dissolve your solid ones, you know. Oh, safety considerations. Just search it up. Just search it up. If you don't want to search it up, just, you know, ask Mr. GPT. So question 6 isn't asking you how to start the machine. No! It's not asking you how to start the machine. It's asking you how to get this curve, which is called the calibration curve. So how does the calibration happen? I'm not going to go over that again. Okay, let's do mass. Let's do mass. That was previous. Okay, mass. By the way, while I've got my PowerPoint up on the screen, I can't see any of the comments. So I'll have to periodically stop the PowerPoint and look at the comments if there's any comments. Okay, let's do this. Mass spectrometry. Just a quick way that I like to remember whether it's spectroscopy or spectrometry. The M of the mass and the M in the spectrometry. Genius. So smart. And also spectrometry, you're measuring something actually. Yeah, I don't know, just the M's. Anyway, sorry. Outline how the machine can give you qualitative and quantitative analysis, and then these are your steps. Vaporization, ionization, you get it. Okay, what is this process? This is where you take a few ions and you sort them out based on their mass to charge ratio. Mass to charge ratio. So you have the mass of your ion, which you will know because you have a periodic table, and then the person doing the mass spectrometry will also know because they have a periodic table, and then you're going to divide that by the charge of the cat ion. And in a second, I think I'll show you why it's almost always a cat ion, so a positive ion. This method is used to quantitatively, so counting, measuring, quantitatively determine the concentration of solutions, and also qualitatively it will describe or specifically identify what elements are in the solution. It's a very, very handy machine. The quantitative analysis. Okay, this is very similar to the AAS that we just did. You're still going to do the same thing as before with your calibration solutions. You're going to have a few known concentrations of solutions. You're going to put it through the machine, and it's going to give you a count this time, not an absorbance. There's no light in this scenario for your mass spectrometry. It's going to literally count how many of each of those particles there are. Okay, so in your concentration, for example, in your 1 parts per million concentration, for example, the machine is going to count 6,248 particles, 6,248 ions that went through that machine at this concentration of 1 parts per million. And then it's just going to spit out a very similar linear graph. I don't know if this is logarithmic as well. You don't need to know, but it's going to give you a straight line. Actually, no, it's probably just going to be linear. It's probably just going to be a linear relationship, because that's doubling and that's doubling. No, 2.5. I don't know, whatever. is going to give you a straight line. This is how you are going to calibrate your mass spectrometer. Yep. Known concentrations. Okay, let's keep going. Oh, very good. I like that this is here. Can you, given this calibration curve, can you now identify the concentration of a solution which has 5,000 particles? How would you do that? You would go to your y-axis, find where you have your 5,000 mark, go through and intersect with your calibration curve, and drop straight down. You're getting about 0.83 parts per million. Not very many. Anyway, same thing for here, 15,000, go up here, intersect with your calibration curve, go down 2.4. That's how you do your quantitative analysis, literal counting. Is this gonna go, or it does the thing. 0.8. I said 0.8. Yep. 2.3. I don't know. It looks more like 2.4 to me. Anyway, qualitative analysis. So yep, the same solution, you can put it through the machine and it will give you a mass spectrum. So this here with the peaks is your mass spectrum. So anytime we say mass spectrum, this is the kind of graph that we're looking for. The previous graph, this is just a calibration graph. Okay, same as your AAS, this is your calibration graph. When we talk about mass spectrums, or spectra rather, we're talking about these peaks. Sorry, my wife has texted me. Give me a second. Sorry, bit unprofessional, but we move. Yes, mass spectrum. This graph will show you in that solution what particles did you have, and is going to do that. Is going to identify the particles by this little denotation. Is that the word? Denotion? I don't know. Mass divided by Z. Z being charge. So back here, back here we did mass divided by charge, M divided by Z. That's exactly what is down here. Okay, so it's going to show you in order of mass to charge ratio. So this element down here at 92 has a decent amount of mass to charge ratio, but 98 and 100 and all of those have more of a ratio. The way that you're going to interpret the y-axis, so that all of that was the x-axis, the y-axis is just going to show you how much percentage did 92 have? How much percentage was how much percentage of the solution was 92? How much percentage of the solution was 98? So if you add up all of these percentages for all of these peaks, they should come out to 100%. You're just going to divvy those percentages up, which is why it's called relative abundance. Here's a nice example actually of magnesium and all of its isotopes. So keep in mind the masses are going to be different, and so the isotope with the lower mass is going to be further left on your x-axis. As your mass goes up, your mass to charge ratio will go up as well. In this example, magnesium 24 is very, very abundant. If you look on a periodic table, it should say under magnesium 24 point something. So 24 is the most abundant, but because it's 24 point something, the other isotopes have to be greater than 24. So 10% of it is 25 or magnesium 25, 11% of it is magnesium 26. add all of those percentages up together, you should get to 100%. Okay. So yes, ideally, and most times this is true, all of these peaks will belong to the same element. Sometimes they don't. But in this example here for magnesium, we know they all belong to the same element. And that's cool, I guess. That's nice. Okay. Let me just pause there really quick in between. Before we go to how it works. Let me just pause and look at the comments. One sec. Less deflection. Oh my goodness, there's someone writing Chinese. That is Chinese. Yeah, it is Chinese. Or kanji, I don't know. Wait. Where was the last time I read? Okay. Is the reason we're doing a YouTube live stream because the test is going to be very difficult? I don't know, it's just a thought. No, it's because I wasn't able to go through those PowerPoints or these PowerPoints with you in class, and I felt so guilty. And so I'm doing this for you guys. Can you turn this into a Kahoot? I guess. Is that what you want to be doing as preparation before your first ATAR assessment? Ain't no way is that Daniel. Okay. Subway service screen. Oh gosh. Can I do that? Wait, let me see. Let me see. Sorry, I'm just amused now. Subway surfers. It's not doing it. It's not doing it. It's not doing it. Anyway. Do we need to know mass calibration graph? It's not in the task sheet! Let's see. So angry. So angry. Yeah, I guess it's not in the task sheet. But also, how much harder is, I mean, this is, I mean, like, it's where is it? Look, it's the same process as up here. You just change the y-axis. That's all you're doing. Realistically. Right? I don't know. I think you should be okay. I think you'll be okay. What's no Chinese propaganda? Yep. Counts per second. I don't know what counts per second is. Oh, counts per second. Sorry. Wait, was the question already answered for you? I've missed so many comments. This is so sad. Does a higher mass to charge ratio cause less deflection at the magnetic field? Kevin, it in fact does. Yes, it does. Nice work. Yes, it does. How to use mass spectrometry for qualitative analysis. So the qualitative there is just saying what elements there are. Technically, you're not measuring anything. It's just, your data is, oh, we have gold, and that's pretty qualitative. That's what the qualitative is. Kevin, the answer is no. Sorry, Kim, the answer was actually yes, I think. Was it? Wait. Give me a sec. No, the bigger the mass, the less deflection. Bigger the mass, less deflection, I think. Yes. Okay. Are you guys in your own little voice chat? That's cute. Higher mass to charge ratio will cause smaller deflection. So if you think about, okay, so let's say your mass is 55, and let's say the charge is a 3. I don't know. Let's say your mass is 55, charge is 3. Charge is going to stay the same, but let's say your mass. Oh, give me a Bible verse. Let's go. Mass goes up. Wait, what was the number? 18.3 recurrent. Your mass goes up. The deflection. Wait, what am I saying? There's just more mass. Okay, if there's more mass, your mass to charge ratio is going to keep increasing. Mass to charge ratio increasing. Okay, so you're going to go further right on the wrong PowerPoint. You're going to keep going right as your mass to charge ratio goes up, but as it becomes heavier, it's going to be more resistant to a change in its velocity. Newton's law of inertia. So more mass, less deflection. So Kevin was correct. More mass, less deflection. A light mass to charge ratio causes a higher deflection. You're right. Yes. Higher mass to charge ratio means higher mass to charge. So higher mass, yes. So higher mass is less deflection, yes. Higher mass, low deflection. So what? So Kim has just gone back on his word. What? No. Yes. I don't know. Heavier particles with same charge, less deflections. Yes. Okay. What does relative abundance mean in the graph? Relative abundance is trying to say how much of each of these things there are. So magnesium 79%, 10%, and 11%. You add them all together, you get 100%. The word relative is there because you're comparing those guys against each other. Isn't deflection what measures mass to charge ratio? No, the deflection is not what measures the mass to charge ratio. The mass to charge ratio is just a calculation you do outside the machine. The mass is increasing, let's say, but the charge is not going to increase. The deflection is going to change based on the mass to charge ratio. More mass to charge ratio, more deflection. Less deflection. Oh my gosh. Mute tab. I'm so sorry. Why is it taking so long to catch up to the comments? He literally said the opposite, pal. The higher the mass to charge ratio, less deflection. Yes. Okay, we've established this. We've established it. Don't listen to Kim. He don't know what he's talking about. We were right, Kevin. Oh my gosh, some tribe mentality happening here. So how many isotopes? Kim, what do you mean by how many isotopes? Would we need to know how to calculate relative atomic mass because it is related to mass spectrum and like the formula for it? You don't need to know how to calculate the relative atomic mass. It's not in the questions. Do you need a calculator? Probably not. Bring one anyway. Like, you probably won't use it, but bring a ruler. That would be a good idea. Who is this Kim, by the way? I don't like your tone. Okay, do we need a calculator? I don't like that tone. I'm joking, by the way. I'm only joking. A faction formation in the chat right now. Yep. One question at a time. How long are the extended response, like, averagely? I'll just show you the paper, shall I? Oh gosh. How long are they on average? I'm trying to remember. Like, no, I'm not gonna. Think of like maybe like 6 or 7 marks. So 6 or 7 points. I don't know. There are also, like, it's not going to be just extended response. It's going to be short answer as well. So, buddy, do you want him to say 5.642 minutes per question? No, when Sadhna said how long, I think how much you have to write, not time. I think. I don't know. Leon, you're right, I won't. You're so right. You're so right. Okay. We should probably ban Kim at this point. Wait. Kim, are you a chemistry student? Kim, are you Daniel, are you a chemistry student? Because if you are more than welcome to continue sitting here. Wait, so one last question. We don't need to know CTR because apparently Leon said we do. Okay, Kim. Okay, yes. Okay, you can stay. Do you need to know CTR? Man, we're not up to that part yet. We're not up to that part yet. Let's see what the PowerPoint says. Back to the PowerPoint. Ew. Okay, I can't see your comments for a little bit. He's in my chemistry. Yes, I can continue with the PowerPoint. Sorry, Tina. Apologies. Stop this. Okay, here's the steps. Here's the steps of mass spectrometry. First, you have vaporization, heating the solution to form a vapor. Usually your solution, of course, solute, solvent, is in liquid state, kind of hard to deal with, so you vaporize it. Next, that vapor that you've just turned from liquid to gas, you're going to have to ionize it. And again, I'll remind you what ionizing is when you're taking a normal ground state atom and you remove or add more electrons. If there's some sort of variance in your electrons, there's your ion. First, we're going to remove the solvent, and you're going to make the atoms into ions. Once they are ions, now they are charged. Once they are charged, you can accelerate them. You can manipulate them better. Driving the ions at speed towards the mass discriminator. That sounds like a Doofenshmirtz invention. And then deflection. Once they are going at speed, at this point, now this is where your mass comes into play. The ions are going to start getting deflected at different extents. Your ions are going to be deflected to different extents based on how much mass they have. And then your detection, it will determine how many ions there are. So before I showed you this graph, to get those peaks and to get those percentages, you're going to have to count every single one of those ions. Okay, let's keep going. First step, Vaporization. Your liquid sample in your test tubes are going to be put into the spray chamber here. In this glass chamber, this is where your liquid becomes a gas, and then it's spat out to do something else. Mist is drawn into the tube called a torch, where it reaches an ionization source. So liquid, still liquid, goes into the spray chamber, and around here there's probably some sort of nozzle or something to make that liquid go through with high pressure, which will make it into your gaseous state. And then you go into this torch here. Now you don't need to know this whole diagram. This is too complex. You don't need to know all of this. All you need to know from this diagram is that at the spray chamber, your liquid solution sample becomes a mist, or becomes gaseous in nature. That's it. There's your vaporization done. After it has become vapor, now is the fun part, your ionization. Oh, that's an actual photo. Very cool. So plasma, very, very hot plasma, is where your freshly vaporized solution is going to go through. So the mist goes into the plasma, and it evaporates, and all that is left over now is your ions. So your solution before in the liquid state had, let's say, water mixed in with gold ions. At this point, the water that is in the vapor is going to be removed, and all that is left over now is your gold ions. Okay, then your ions are forced through these cones, and so there's the coil, by the way, the RF coil. Let me just go back one slide, one sec. Here's your RF coil. Your liquid goes through, sprayed through the to the torch. Keep your eye on that RF coil. Bam, RF coil. So your sample is going through here, is burned up at this point, and all of that is just ions. How cool is that? That's all charged particles going through a very, very small hole in the plate, which makes sure that you now have a beam of just ions. There you go, ionization done. Once your ions are pushed through, let me just go back one sec. Once your ions are pushed through this plate, they go through the source slit, which realistically is the same thing as the cones. It goes to your quadruple rods. Now, so many people ask me about quadruple rods. Feel free to talk about quadruple rods. This is one of your models of mass spectrometers that does accelerate your freshly made ions through to the detector. Okay, let's read. The ion beam is then accelerated through a magnetic set of rods. These are your quadruples. The rods deflect one type of ion towards the detector, and all the other type of ion is sort of attracted and removed, so that you have a pure stream or pure beam at the end of the ion that you want to look at. So we're using pink here to denote that we have blue and red ions mixed together. Once this charged particle gets in the presence of these magnetic rods, they start moving around a bit. They start moving all funky. The blue particle in this case is the one that we don't want. This is what we call our non-resonance ions. You don't have to know that term. You don't need to know resonant and non-resonant ions. You just need to know that one type of ion is not going to be participating in the detection after it exits the quadruple rods. The ion that we do want gets bounced around and pushed through the exit slit. Don't ask me why one of these ions doesn't get through. It just does. If you can come up with an answer, please tell me. I'm so curious. Let's keep going. Finally, detection. This is a real life mass spectrum, by the way. Very, very cool. The detector for the instrument is called an electron multiplier. Sick. It counts every single ion that comes through the other end, so this exit slit. Every ion that goes through immediately, almost immediately, hits the detector to be detected. Actually, not immediately. No. I feel like there's a slide missing. I'll come back to that. But the detection at the end counts every ion and it spits out this graph which will tell you, oh, look at the mass down the bottom. Calcium, chromium, manganese, all of these are in order as seen on the periodic table. Very, very cool. When you add all of these percentages up, it should come out to 100% of the sample. But this is a very very varied sample. There's too many elements happening. Ideally, you would get something like this. If I could zoom in, I would. But just direct your eyes to the lead down the bottom right here. Usually, this is what your mass spectrum is going to look like. So you have 1, 2, 3 peaks, all of them being lead. All of them have different masses. All of them also have the same charge. They all have the same charge. As you go further down to the right, your mass increases. This one, the heaviest peak, is your heaviest isotope. These ones just a little bit lighter. So this heavy isotope is going to get the least amount of deflection because it has the most mass. The lightest isotope is going to get the most amount of deflection because it has the least mass. Okay, I don't know how this has happened, but the deflection, I need to show you the deflection. Let me bring up a diagram. Just search it up. Mass spectrometry, sure. This is the diagram that I've been showing you and talking to you about. Oh, Khan Academy. Open image. There we go. Yeah, the acceleration slide has both acceleration and deflection, but I want you to see this one. I want you to see this one. This one's a good one. Oh wait, there was one with like dots at the end. Here, that's the one. The one with the dots. Okay, let me remind you really quick what the steps are. Where's my slide? Okay, vaporization, ionization, acceleration, deflection, and detection. Okay. On the very left in this diagram, this is a very simple diagram. I like this diagram. If we ask you to draw a diagram like this, I wouldn't mind if you did a diagram like this. Here is your sample injection. You don't need to know that specific terminology. You can just say vaporization. Okay, so your sample has been vaporized and it has been ionized here as well, okay, with your electron beam. Your electrons are going and bombarding your freshly made vapor. Some electrons are being smashed out of their energy levels. Some are taking new places. So you're getting your ions, charged particles. Those charged particles, let me just go back to this. So you got your vaporization, you got your ionization. Now you're going to get some acceleration. Your charged particles are going through the magnetic well, this is a charged magnetic region anyway. It accelerates the charged particles. They go into this magnetic field rather. They go into this magnetic field. Now the deflection. One sec. Deflection, very important. Oh. Wait, can I draw on this? Image. Draw an image. Can I? No, I can't. Anyway, we are going to assume that all of these ions, if not interrupted with, they're just going to keep going straight. Okay? They're just going to keep going straight. That's what you have to keep in mind. If this magnetic field wasn't here, they would just go straight. Now, the heavier isotopes, the ones with more neutrons in their nucleus, the heavier isotopes, are not going to deflect as much. So if this is our natural path of the ion, the element or the isotope that is least deflected has to be the heaviest isotope. Again, if this is your normal path of your isotope or your ion, the ion that is most, or the isotope that is most deflected must have the lowest mass. It's just the rule of inertia. Atoms or matter with more mass is going to take more force to move them than matter with less mass. So the less mass, very easy to deflect. More mass, harder to deflect. Okay? This is why the detector can detect the different isotopes. This is where you can detect your different isotopes. I'm saying that really emphatically because look at this. Explain how a specific analyte or isotope can be isolated for detection. Why is this possible? Because they have different masses but the same charge. So the isotopes with the greater mass are going to be deflected the least. The isotopes with the least mass are going to be deflected the most. Okay. Oh my gosh, I've been going for an hour. One sec, I just need to look at the comments and what you're saying. Do we need to know this because I didn't find it when researching? The cathode ray tube? No, you can use what's in the PowerPoint. You can do quadrupoles if you like. You just need something. Like you need to be able to tell me. Oh, wrong one. You need to be able to tell me what does the vaporization, what does the ionization, what part does the acceleration, what part does the deflection, what part does the detection, and then what do each of those parts, like what happens at each of those parts. So the residual gas particles exit through the vacuum pump. Yep. It's missing deflection. Wait, never mind. Okay. Is it because that one type of ion cannot be affected or manipulated by the magnetic field, like the magnetic field is specific to the analyte being measured? No. Anything that is charged that goes through a magnetic field is going to have a force applied onto it. And because of that, anything that is charged that goes through this machine is going to be deflected to some extent. The only thing that is not going to be deflected is anything that is not charged. So as long as your particle has been ionized, it will be deflected. I had no idea the atoms get burned. Can you go back to that part? Do they get burned? Here, this part here. The plasma. So plasma, extremely high temperature. The mist enters the plasma, the liquid evaporates, and the ions are left over. That's the burning part. This is one way of doing the ionization. If you did your own research and you came up with the electron beam example, go ahead. They're both correct. Okay, they're just different machines. They're both correct though. Did you sleep before tests or no? Yeah, I slept before tests. Are you planning not to? Because I would actually really recommend that you get some sleep. In the ionization, because you can get like delusional if you don't sleep. Like not delusional, delirious. That's the word. Delirious. Oh, that's not how you spell delirious. One sec. I need to know if that's the right word. Oh my gosh, can you not? Disturbed state of mind. Yep, that's the word. So in the ionization stage, can the mass spectrometer use an electron beam instead of plasma? Absolutely, Kevin. Absolutely. One or the other is good. What does the CPS bit on the mass spectrum graph stand for? Child Protection Services. Wait, let me just find it. CPS. Oh, count per second. Count per second. Here. Counts per second. So every second, it's counting how many. So CPS is just how many particles per second. What is atomization? Weight is atomization same as ionization? Nope. Two different things. Atomization and vaporization synonymous. I can't edit it. Why can't I edit it? I can't edit it. Vaporization and atomization, same thing. Ooh, not now. Ooh, vaporization equals atomization. You're doing the same thing. Technically, you could say atomization is part or comes in the vaporization section, but like here, look, the plasma makes it ions, but before that, vaporization, atomization, you can use them interchangeably. I don't mind. This PowerPoint still hasn't been uploaded. It's so weird. Here, wait. I can prove to you that on my side, it is uploaded. Here, look. Resources. Uploaded. And I don't know what to do to get it to upload to you, because look. I'm showing you all the trade secrets, but I've uploaded it here for you on Wednesday. So if you can't find it on resources, maybe go to Wednesday and have a look. I don't know. I don't really know. It's there. It's there. Weird, right? So in the electron beam, there's no burning. No. In the electron beam, there is no burning. Just blasting with electrons. Here, we'll ask Mr. GPT. How does electron beam in mass spectrometer ionize? Collision with sample particles. The high energy electrons collide with the neutral sample particles and they make them... Oh, this is actually getting complex. Let's not do that. Anyway, you can use electron beam or you can do the plasma. Either or. Both of them are not going to be in the same machine at the same time. I think counts per second. Nice work, Ella. Well done. It was counts per second. I did both electron beam. Okay. Good on you. You got the PowerPoint. Interesting. So we don't need flame test, right? It's in the task sheet, but I was confused because certain people were saying we do. Certain people are misleading you, sir. where? Flame test. Flame test? Man. No, there's no flame test. What flame test? I don't understand. We don't need flame test, right? It's in the task sheet. It's not in the task sheet. The only thing that's close to the flame test is this one here. How the atom absorbs and emits. Mr. Daly didn't provide this PPT. Yeah, he sent out an email, right? And this PowerPoint wasn't there. But a couple of people from my class came up to me and said, "Sir, the other class got it." And so what am I gonna do? I'm gonna provide for my kids. So there you go. What does the RF coil do again? The RF coil, is there to heat up the sample. So it's like a solenoid situation. It just heats up whatever is inside of that coil, which is why you can get this really, really hot plasma. Let me show you real quick. Another application of this. One sec. Solenoid heating metal. Here. Like this. So you've got your RF coil. Look how fast that heats up. Heats up so fast. So fast. It's so good. This is what's in your induction stoves, by the way. Or similar. So that's what's happening. That's what's happening with your RF coil. The RF coil here. All the ions going through there are being absolutely burnt, which is why you've got this plasma here. Cool. Didn't give us a PowerPoint either. I can email it to y'all. Thank you, Sadhana, doing the Lord's work. Oh, let's go, Leon. Okay, so it's come through somehow. Okay, that's good. Yeah, the RF coil will heat up the mist, burn it up. But Kevin, the more important question is, what does heating up the mist do? What does it do in the process? Like, what does the heating up do? Kim, if you fail tomorrow, it's not anyone else's fault. You've been given all of this, man. All of this. You have the wonders of the internet. Kevin, vaporize, yep. And also, where's my PowerPoint? It vaporizes, and here's the important part. It ionizes. Okay, so don't get hung up on what the RF coil does. Get hung up on what vaporization is and what the plasma does. It ionizes. For question 8 of AAS. Question 8 of AAS. The internet said things like filtration and digestion and matrices. Or matrices. That's not the right way to answer it, right? Nah. Doing too much. Sorry. Not the right way to answer. I wonder what ChatGPT will say. Where is it? 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 Yep, liquids. Oh, voice crack. I'm gonna quit. Liquid samples you dilute with water. Don't worry about digestion. Don't worry about filtration. Don't worry about standardization. Standardization's good. Standardization's good, I suppose. But if it's an unknown value, unknown concentration, it's kind of hard to standardize. You don't know the concentration. But for a concentration that you don't know, dilution's fine. Dissolution, oh, stop it. Just make sure it's in a liquid state. You can do that either by digestion. You can do it by just trying to dissolve it in water. I wrote about filtration and digestion and thingies too. That's fine, LA. If that's your prerogative. If that, yep, that's fine. That's fine. But again, I would encourage you to think about why we are asking that question. We're asking that question to see if you can relate it back to what the AAS machine does. The AAS machine burns up a sample in a flame, and to do that, you're going to need your samples to be in a liquid state. Solids are not in a liquid state, so you're going to have to digest them or dissolve them. So yeah. So it's okay to use ChatGPT for the research part. First of all, too late to be asking about the research part. Second of all, I would encourage you not to do that and not to tell anyone that you did that, because that's plagiarism. If you're going to use ChatGPT like I did, you're going to have to write in your own words and find your own references for your bibliography. I said liquid samples are introduced into the chamber and breaks into fine droplets and directed through flame, and solids are atomized. Yeah, sure. You're trying to get to that, the vaporized, atomized state. How do you get your liquids there? And then how do you get your solids there? Would adjusting pH be one of the preparations of liquid samples? No. You shouldn't have to adjust any pH or anything like that, because if you're adjusting pH, you're adding a acid or a base, and that's going to contaminate your sample. So don't worry about pH stuff. Don't worry about pH. I don't think AAS can analyze solids, right? No. The AAS cannot analyze any solids, but if you have, for example, a solid bit of gold and you want to analyze that, you can dissolve that in maybe an acid, and then that you can then vaporize, and now you have your gold ions, and that's easier to analyze. So you can't really analyze your solids in your AAS, but once it's a liquid state or once it's a gaseous state, then you can analyze that. Yeah. Are y'all AI checking the notes? Asking for a friend, but do they real check if you use GPT or not? Yeah, it's actually very easy to do. AI checker, like there's so many that we'll just put your text in there and it will just tell us. I'm not going to tell you which one we use, but it will just tell us if you're likely to use ChatGPT or not, or any other AIs. I don't know if that's right though. Evan, that does sound right. That does sound right. That does sound right. So yeah, with your AAS, again, I'll remind you. Let me show the diagram, the vague diagram. To get your test sample into the flame and to make sure it burns, you've got to mix it with, where is it? A combination of air and gases. So you've got to have those. And to make sure that it's a good solution, you've got to make your own sample a gas as well and mix it in with this stuff so it's nice and easy to burn. So solids can't really do that. But if you really wanted to analyze a solid, dissolve it. so that it can be vaporized and mixed with air. What if you hand wrote your notes? Yeah, that's fine. You can handwrite your notes. That's fine. You still need a bibliography. I recommend maybe print out a bibliography and stick it to your physical notes, perhaps. I don't know. If we did the notes online, do we print it out and bring it in, or email it? What does the task sheet say, actually? It doesn't say anything. If you have access to a printer, print it. If you don't have access to a printer, I would rather you just hand it, I would rather you just submit it on time. So if the printer is your limiting factor, like if you can't get to a printer for a physical copy, then you can just send me a electronic copy. But yeah, I would rather get your notes on time so that I can start marking, okay? And so that I don't have to deduct any marks. So get those notes to me. Daly, I think you mean Mr. Daly, said he doesn't really care. Is the bibliography marked though? Here, I'll point you back to this one here. Deductions of marks on your research notes. Yeah, I'll be a teacher tomorrow, Evan, for the period 0. I'll be in your class. There'll probably be some other. Thanks, Pasha. There'll probably be some other students in there as well, but I'll be in there with my class. I'm sick of talking. Don't ever delete this video so I can come back to it later. Oh, Esley. Hi, Esley. Were you here the whole time? No shot. No, I think that's your first one. Yeah, I'll try not to delete it. I'll try to make it available as soon as possible as well. Yeah, if you have any questions about what is on this sheet with your spectroscopy and spectrometry and whatnot, I'm willing to answer those. Anything other than that, like, it's a bit late. Like, why? Don't bother. Don't bother. Just show up on the day. Show up at 7:20. Have your notes there, ready to go, and that's good. I'm a G for real. Thanks, man. You know who is a G? Mr. Daly. Mr. Daly's a G. Love him with his Star Wars shirts. Gosh, so cute. No, I just came earlier. Oh, okay. D1 Glazer. Oh, gosh. Have we had enough? Should we have the evening to ourselves or what? If we don't have any more questions, we will be good, right, tomorrow? Yeah, you'll be good. You'll be fine. You'll be all good. Don't even worry about it. I think you're underestimating how good you are. So, by the way, don't forget to do these 3 questions up the top. No one's asked me any questions about these ones up the top. Make sure you get that down pat as well. Make a Kahoot. Okay, Sadhana said wait. Okay, I'll wait. So if I submit something with AI and y'all find out, what will happen? Deductions of marks. And also plagiarism. I'll have to talk to the head of science, because if we can detect some sort of plagiarism, it's the same thing as collusion, like when you're talking to someone in the test trying to get their answers. Last year I caught one of my students cheating, and they got 0 on the test. So as much as you can, if you do use AI, try not to copy paste, because that's very easy to detect. But also, just type up your notes. They've got to be your notes at the end of the day. And the point really of the research notes is to make sure that you are comfortable with this topic and that you've researched it enough that you know it in and out, so that you can answer all of these questions that are on this task sheet. And if you can do that, you'll be okay on the day. Tomorrow. If do you just not want to talk to us? Well, Esli, you've said 3 things, so who doesn't want to talk to who? If, Sadna, lots of ifs and buts here. I don't deal in ifs and buts. I only deal in absolutes. Wait, I've got to find it. I don't deal in ifs and buts. Oh, if, buts and maybes. There's maybes as well. This is me. I
said it last time I was on it. He's the best football player in the world. I don't know why people. Why he's laughing for? What, Chris? Why are you laughing for? Why are you laughing for? I'm being serious. No, you see. I'm talking facts here. I don't do if, buts, and maybes. I do absolute. What I'm trying to say is
absolutes. I do absolutes. Can you Loki make a Kahoot, sir? What do you mean by make a Kahoot? Like what? Would you want me to type up questions in front of you and then show you what the answers are so you can, I don't know what. But AI isn't there in the test, but the notes are part of the assessment. So technically, if someone never saw the PowerPoints, could they still get 100? Absolutely. The internet has more information. So yes. Is it a possibility? Yes. Sir, doing too much. Stop, Patra. You know that was funny. Bro is giggling behind his screen. Is it possible for a 100 this test? Yeah. What? Why would it not be possible? Host a Kahoot for everyone. In the chat. Winner gets lollipop and a free 100. What is 100? 100 what? What's your units of 100? For the rest. Oh, free 100 marks. For the rest of the year. That seems unreasonable. What? Saw what you watch on YouTube. Nice work, Leon. Detective over here. Come on now. The notes aren't there in the test either. Bro, just let me use it. Sadhana, I'm going to screenshot this and send it to my head of science. Wait. Do you want the Kahoot to be about chemistry? I don't know if I can even host a Kahoot. Like, I don't have that sort of facilities, big man. Ew, I'm saying so many cringe things. Sorry, I'm so tired. I'm saying all the cringe things. Oh, that's my account, so you don't need to know that. Am I brave enough? Oh no, it will auto login. Okay. What else would a Kahoot be about? I don't know. Like you've just said Kahoot. You haven't said chemistry Kahoot. I'm just gonna search one up because I can't be bothered making one for you. And mass spectrometry. Chemistry. Whoa, Patrick. Mod 8 review, I guess. Bromine water. Okay, we're doing organic chem. Let's flip and go. You didn't mean that. What do you mean? You did. What did you not mean? Fake. Wait, what? What? You didn't mean that. I don't get it. How many principles of green chemistry are there? Oh, you can do this one. Oh, I just gave away the answer. I'm sorry. No, this is too vague. Let's see if it just does mass spectroscopy. Oh, Daniel, are you saying sorry because you said buddy? That's nice of you. Oi, Essie, stop! I'm about to ban you. I've turned a new leaf. Oh gosh, I forgot I showed you guys that PowerPoint. Goodness me. Hey, why not? Let's host this live. Let's go. Join if you like. Up to 40 players. Amazing. There you go. Can you get a house tour? Do you see a camera? What you want an audio house tour? 3D audio house tour? Bro's just saying things. So just so you know, you are my number one. See, that's what I'm talking about. Yes, Cecily, it's about mass spectrometry. I'm gonna go try and grab my cat and get her to say something in the mic, and then that would be your house talk. Give me a second. Hey, say something. Say something. Say something. Say something. There we go. Something else? Anything else? Anything else you have to say to the masses? Ooh, interesting opinions. Okay, there's your... Oh, come on, Pashva. No class. No class. Whoa, this is a lot of people. I didn't realize I was talking to this many people. How cute is the cat, by the way? Controversial take, truly. I speak to my cat. Yep. Yeah, true. I do know what she was saying. She was saying I don't know. No video, so sad. Maybe next time I have to do a desperate live stream like this, I'll do a video. Show us the cat. Okay, Sadhna. Truly, how would I do that? I might be unprofessional, but I could show you a video at school on my phone. I don't know. Scaling for these tests? Evan, no scaling yet. Scaling will be when we compare our assessments to ATAR assessments. Okay, let's get started. Let's just go. I'm not turning my camera on. The output of a mass spectrometer that is analyzed, dude. What's it called? Face review. Guys, answer. Why aren't we answering? Wait, why aren't we answering? Wait, one person has answered. Wait, what is this? What is this? Diddy! No. Why is Diddy winning my quiz? Wait, what's happening? Wait, what's happening? Extremely delayed. Extremely delayed. I don't know. I don't know really what to do about that. Oh. The lag. Horrible Wi-Fi on your end. I'm on Ethernet, actually. Actually, I'm on Ethernet. Oh, time limit up. Oh my gosh, genius. Okay, wait. I'm gonna end this real quick. Sorry about this. I'm gonna end this and then we'll start a new one. Can you not? Can you not? I can't. Oh, here. Wait, who won? Oh yeah, Diddy. Diddy won my chemistry test. Edit the Kahoot. Wait! You can't see that. Man, this is so much effort for not much payoff, to be very honest with you. 3 minutes. 3 minutes. 3 minutes. 3 minute lag would be so funny. 3 minutes. Okay. Oh wait, no, not duplicate. Let's well. Delete. Play solo. Kahoot has a play solo option. How is that? Play solo is crazy work. Okay, there we go. Sorry, it's up now. New code, Evan. Wait, Sadhna, are you Diddy? Wait, it actually is so delayed. What do you mean payoff? Like I get nothing from this. I just get to waste more of my evening. Adopt me, please. No. No. Evan, no, that was not the test. That was we started it, but lots of lag, so we had to restart it. Okay, Sadhna is not Diddy. I'm not gonna ask who Adopt Me Please is, because that will make things weird. I will never see you the same way again. I know who this one is. Probably Daniel. I don't know. Maybe. I don't know. I get to spend my evening with you. Oh, isn't that nice? Yeah, the live stream is just delaying it. That's just how things are. It's not anyone's fault. How about we don't blame each other? And how about we blame the sharks in the ocean that are eating the internet line? That's who I'm gonna blame. Leon, my internet is not whack. You're whack. Oh wait, you are literally just Daniel. Yeah, apologies. Reporting my live stream? No. What will I do if my live stream just ended suddenly because someone reported it? No. Oh, actually, let me show you this. Excellent connection, Leon. The Kahoot game, the Kahoot is going to help you get an additional 5%. It's not actually, but. A 180 seconds. Wowee, the lag. Whoa, that's literally taking 30 seconds. Nuts. Damn, who's still going? At that point, surely it's not my internet's fault, right? Guys, what is this? Why have we chosen this? No. Mass. Adopt me, please. No. Why must it be you? Oh, LeBron James. Oh my gosh, guys, LeBron James is in my lobby. Next question. On the axes. This is both of them. Wow, lagging. Stop, Esley. The word lobby just fell out of my mouth. It just rolls off the tongue. It just rolls off the tongue. I don't know. Lobby just rolls off the tongue. LeBron James is in my Kahoot lobby. Time to delete stream. Didn't it? I swear you said don't delete this video. Here, Esley, circa 2025. Hi Queen, don't ever delete this video so I can come back to it later. Oh, hey, much better results. Okay. I like this, keep going. Principle that allows mass spectrometry to work. Delete Steam. Delete Steam. I'm not gonna delete Steam. Oh gosh. My gosh, it takes more than a minute to get through one question on Kahoot. By golly. Hey, red and yellow are very similar. Red and yellow are very similar. Not different charters. That's just that one's just wrong. That one's just wrong. But this is very similar. Why have they done that? And an unknown compound has isotopes, different molecular weights. Sorry about that one. They're similar. I don't know. I don't know. Let's go. Big upsets. Big upsets. Holy lag, Daniel. This was your idea. I think. I'm glad we're doing only a small one. Only 8 questions. If we had to do more, I would not. I would just not do that. One way data from mass spectrum can be evaluated. What? Ooh, interesting. Do a guess the food Kahoot. No, Daniel. I will be going to go spend with my wife and cats later. Not doing another Kahoot. That is not even relevant to chemistry. Like, what is your intention here? Are you here to study? Guys, man, it cannot take 90 seconds to answer a question. Cats plural. Yeah, cats plural. The girl that I brought in earlier, I got very recently. It was a gift from my wife for Valentine's Day. Very, very cute. Oh, I'm gonna skip. I can't be bothered anymore. Sorry, I'm gonna skip. All of the above. Stop messing around, cat review. Again, I can't. I don't have a camera. Don't have a camera. All right, all right. I need to let the other cat in. I'll be back in a sec. Got my other cat here now. He doesn't say much, but he purrs. Listen. Say hi, bro. Say hi. The molecular ion has a mass of... Who knows? Who cares? Wait, could you actually hear it very clearly, or are you being sarcastic with the ellipses at the end of that sentence? I don't know. Bring it to school. By the way, this question is not even like, it's not even going to be tested. You're not going to be tested on this. You're not going to be tested. So I'm just going to let it run for the purpose of the Kahoot. But apart from that, you don't need to know this. So oh, you couldn't hear? No, he has the cutest purse. He when he was when he was adopted, he was called Motor because of how loud he was when he purred, and he is quite loud, and his whole body vibrates. It's very cute. Guys, let's just not. It was yellow, by the way. 72, the highest peak probably. I don't know. R of out of nowhere. Well, actually not out of nowhere. You've been at the top for a bit, but the most abundant molecule or fragment in this sample. Most abundant. You should be able to do this. Like this sort of graph you should be able to read. Like this is a mass spectrum that you need to know how to interpret, is what I'm trying to say. Oh, Esley, his name now is Bo, not Shreya. Oh wait, no, wait, Shreya is actually a person in here. Oh my gosh, I'm so stupid. I'm so stupid. Did it say green? I don't know. I'm sorry, I couldn't tell you. I don't know. I don't know. It was green? Okay, Arav, thank you. Please, his name be Evan. Bow like Brawl Stars? No, bow like beautiful. The first 4 letters of beautiful. Hi, Shreya. So for preparing solids, do I need to get a small known amount of the sample for the analytical balance? Is that a thing? Yeah. Depends though. Actually, if you're trying to just find how much gold, for example, is in an ore, you're not going to know how much there is, so you don't really know the amount, if you know what I mean. Like, you don't know the amount. That's what you're trying to figure out. But for your mass spectrometer, if you're trying to prepare a solid, yeah, I think you'll have to dissolve it so that you have a standard concentration. You will do that anyway before for your calibration curve, but yeah. Yes, Ashley, that's correct. Bow like BAU. Can I submit my notes tomorrow if I print them out? Yeah, absolutely. Yeah. Yeah, 72, the tallest peak. Easy. 2 more questions. What is not one of the 3 primary functions of a mass spectrometer? Hey, this is actually a good one. Proper relevant. Oh my goodness, it's almost 7 p.m. Thanks. Happy birthday? Happy birthday. Why are you saying happy birthday? It's really hard to know what you're trying to say over text. Because like in real life... Daniel! Daniel! What are you doing? Why are we sharing the answers? I can't wait for this to be over. In real life. Oh yeah, in real life it's easier to know what you're trying to say because I can like see your expression, but I have no idea if you're being serious about the happy birthday or not. Oh, nice work. Create ions. The word create I don't like there. The more appropriate terminology would be ionized atoms. That would be perfect. We're not going to create ions. We're going to produce ions, I guess. I don't know. I don't like the word create in science. We never create anything. What is the common charge for mass spectroscopy? Oh my god. Oh my god, guys, I have badminton at 7 o'clock and I have to drive there. And I forgot. Because I'm doing this. Kahoot. Oh my goodness. No. Quick, finish this, please. Is delayed by 20 years? Yeah. We could have been done with this ages ago. Where can I get prac questions and stuff? For now, you can get practice questions from, like if you look at the end of each PowerPoint, we have some questions from Essential Chem. You already knew that anyway, but if you want practice questions, you'll have to, if you have the revision book, go ahead, use that. If not, and if you really just want practice questions in different formats, ask AI. Do it. I'd smoke you in badminton, Leon. You don't know who you're talking to. Shush. Oh, thank you, Shreya. I will have fun. Spectroscopy. Spectroscopy. Arav, let's go. Sadhana, and then wait, who's that one? Oh, Leo. I'm assuming that's Anthony. You should hurry, sir. You can make it in time. Yeah, I hope so. I hope so. Because otherwise the uncles will yell at me. That's no good. Okay, thanks guys. That was pretty productive. I'll try and see what I can do about putting the video of this live stream up. Do I play at Armadale? No, I don't play at Armadale. I play at... I'm not saying because it's none of your business. How about that one? Thank you, Esli. I will have fun at badminton. What's my prize? You came second. What do you mean, what's my prize? What's my prize? Okay, Arav can say what's my prize. Arav, I don't know, man. We'll see. Surely free 100. If you can earn it, I will deliver. Prizes for top 5. That's just greedy now. That's greedy. I'll be following up on my prize. Again, you came second. So... What do you mean by keep the video up? Like as in don't stop the stream? Or... Because that's unreasonable. I can try and like upload the video of the stream. I don't know. Yeah, I do hope you all pass. I hope you're not scared of this assessment and this subject yet. It does get a lot more fun, I can promise. I can promise it will get more fun. Prizes for top Angel, no prizes. No prizes. Second is, hey, Sadhana second is good, but also, you know what's better? Yep. Don't delete the stream so I can go back to it. Okay, that's fine. You can save the last stream as a video. Yeah, I thought so. Yeah, I thought so. Save it. Yes, don't end the stream. Sir, how do I move into your class? Too late. It is too late. You have 3 minutes. I do have 3 minutes. That's 3 minutes that I'm supposed to be there. At, I don't know. Sadhana will, hey, let's talk about prizes later. Okay. I think that's all I can help you out with today. Okay. If you have any other questions, save it for someone else. I've got nothing left. I've got nothing left. I need to get to my badminton. Badminton starts in 2 minutes. I'm gonna get whooped. I'm gonna get whooped. Okay. Thanks, guys. Have a good sleep. I would recommend a good sleep. And yep. I'll try not to be. Well, I'm going to be late, aren't I? Guess why I'm gonna be late. Yep. Okay. Okay, thanks guys. Bye bye.